We're first going to look at library of functions, so the 12 basic functions that make up algebra. We're going to talk about the functions, their graphs, domains, and ranges. The first one we're going to talk about is a linear function. The graph of a linear function looks like this. It has this equation. Y equals X. The domain, what's the domain of this graph?
The domain is infinity. Negative infinity to positive.
Very good, because it keeps on going forever and ever. So it's negative infinity to positive infinity, or I could simply just write that R, or I could the R symbol, makes it easier to write. What's the range? How far does it go up and down? Right, it goes all real numbers, very good. Negative infinity, positive infinity, or you can put the R symbol. So that's the first one. Whenever you just have an X, we know it's linear because there's no exponent, there's no anything around it, just X with, it could have a number in front of it or below it, but it cannot have anything else. The second one we're going to look at is called the absolute value function. The absolute value function looks like this. And when we'll talk about that later, but what does an absolute value do? It makes whatever number's inside there, it makes it positive. So if I have an absolute value of -5, it's 5. So the absolute value tells you the distance, how far something is from 0. So -3 is how far from 0? 3 spaces. So the absolute value of -3 is 3. The graph of the absolute value function, since y can never be negative, it looks like this. It's 2 straight lines. Basically, it's this one. It's the linear equation, but I just rotate that negatives to the positive. What's my domain? What's my range?
From 0 to infinity.
Nope. This one goes on forever and ever, both sides. So it's negative infinity to positive infinity. Look at the arrows, it keeps on going. How about the range?
Yeah, from 0 to infinity.
Yeah, so can we use 0? Yes. We can write the range like that. Or we can write the range like this. Because the domain deals with the X and the range deals with the Y. So far, so good. The third one is the quadratic function. I'm not going to put the word functions as extra writing. It looks like this. We know a function is quadratic if the biggest exponent is 2. We call that the degree of the equation. Bless you. We call that the degree of the equation. So in other words, what that says, can X be negative? Can X be positive? Can X be 0? Can X be negative? Can I put negatives in there? Yeah, are you sure? What's -2 squared? -2 times -2. No, positive 4. Can you put 0? What's 0 squared? 0.
No.
0 times 0 is 0. And the positive. So I can have my domain, I could put anything in there from negative infinity to positive infinity. The range, since this is squared, it can never be negative. So it's the same thing as the absolute value. It's from 0 to infinity, or y is greater than equal to 0. Now we have a radical. This one is called a square root. It looks like this. The reason it's called a square root is because there's an invisible 2 right here. There's an invisible 2 right there. The rule here is x, you cannot have a negative inside there. You can, 0 is okay. So when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. Square root of 4 is 2. So the graph looks like this. It's an arc. So what's my domain? How far, where does my x's go? From where to where? Where?
From 0 to infinity.
From 0 to infinity. So I can use 0. 0 exists. So 0 to infinity. Same with the range. Because there's a solid dot there. Or for my domain, I can say x is greater than equal to 0. Y is greater than equal to 0. So that's a square. Now we're going to look at cubic functions. Y equals x cubed. The difference between the squared function, the quadratic, and the cubic function is if the degree is even, I can never have a negative answer. Because -2 times -2 is positive. If I have -2, -2, -2, -2, it's positive. So if you have an even exponent, it's always going to be positive. But if it's odd, then if it's negative, it's negative. If it's positive, it's positive. It's 0, it's 0. In the domain and range, all real numbers. Also, look at this. If the degree is even, the graph always points the same direction. If the degree is odd, it always points opposite direction. This will be very important when we start graphing large order polynomials, large order equations. Now we have a cube root function. Again, if the root, this is a square root, because there's a 2 there. If the root is even, it can never be negative. It's got to be only positive and positive. If the root is odd, it can be positive or negative or 0. So the domain is all real numbers. Range is the same thing. Example 7. These are called exponentials. Functions. These next two are going to be is the whole concept of chapter 5. An exponential function looks like this. Now the x is the exponent. An exponential is b is a whole number. B has to be bigger than 1. It can't be negative, cannot be 0, cannot be 1. It has to be bigger than 1. Now, any exponential function has this graph. And it always crosses through 1. The domain and the range? What's the domain? Yeah, all real numbers. Very good. Because my x's could go on that way and they go on that way. The range, it's got to be above the x-axis. So it's always greater than 0. It never equals 0. Or y is strictly greater than 0. Logarithmic functions. It looks like this. Y equals log base a of x, where a is greater than 1. You cannot have a 0 as a base. You cannot have a negative. What this one looks like is like this. And it crosses through 1. So the domain is greater than 0. So x is strictly greater than 0. And the range, all real numbers. Now we have a rational function. Rational means fraction. So here's the concept. The bigger X becomes, the smaller this number becomes. Or 1/10, 1/100th, 1/1000th. So the bigger X becomes, the smaller it becomes. So it looks like this. And remember, it's a fraction. You cannot have zero on the bottom. So my domain is from negative infinity to zero, and from zero to positive infinity. Same thing for my range. Or X cannot equal zero and Y cannot equal zero. Oop, not equal zero. Now we have another one. This time, if it's squared, if it's 1/x squared, if something is squared, it can never be negative. So since whatever I have is always going to end up be positive, it looks like this. It's like the Atari symbol. The domain is from negative infinity to zero, zero to positive infinity. And the range is strictly everything above zero. The greatest integer function the greatest integer function simply tells you that your answers can only be integers. When X is zero, the answer is zero. When X is 0.5, the answer is zero. When X is 0.9, the answer is zero. Erase the decimal. When X is 1.0, it jumps to one. And it stays there until it gets to two. And then so on and so forth. It continues the same way going down. It's called the stair-step function. My domain is from negative infinity to positive infinity. And my range are only the integers. Then we have a constant function. Where C is any number. So let's say we had C equals 2. This is Y equals 2. The domain is all real numbers. The range Y equals C. Or C. Whatever the number is. Did I give you all the cheat sheets also? Okay, get on the way out today, get these. Let me see here. All right. So let's look at section 1. Let's finish section 1 today. It's pretty short, actually.